Welcome to the AP Physics lecture on kinematics freefall, or what I consider this 1D motion going down. This is our objective. Freefall. Freefall, an object is going to always experience an acceleration due to gravity. Gravity is a phenomenon associated with mass. Objects have mass and are going to be attracted to other masses. The larger or closer the mass is, the greater the pull of gravity is. The pull of gravity causes an object with mass to accelerate towards another object. The acceleration of gravity has already been calculated and determined. Acceleration on gravity on Earth or near its surface is 9.8 meters per second squared, oftenly rounded to 10 meters per second. 10 meters per second squared is used for the multiple choice, and you can use 9.8 meters per second squared otherwise, like the free response. The direction is going to be negative y towards the center of the Earth, because it is always going downwards towards the center of Earth. How does free fall look like? Well, Galileo postulates that an object will fall with the same constant acceleration in the absence of air or other air resistance. If you can do this demonstration by dropping a ball and a paper, you're going to see that the ball hits the floor at the same time. However, once you crumple up the ball, the paper, into like a sphere of some kind and drop it, you're going to see how it hits the floor at the same time, because there is no more air resistance pushing up against the flat piece of paper. So what they did in an experiment was they dropped a feather and a ball in an air-filled tub, and you're going to see that the rock fell down first. But in a vacuated tub, that means all air is sucked out. There's nothing holding it. And they drop it, they're going to see that they drop at the same rate, because they're going to experience the same acceleration in the absence of air resistance. A typical free fall problem has us either dropping a object straight down or tossing it up, then it coming straight down. I want you to look at the vectors. When you throw an object up, it has a positive velocity, but there is always still gravity pulling it down. That is the reason why it's gonna reach the top. At the top, this is when you might see as maximum height. Maximum height, this is when v equals to 0. The reason why it's v equals to 0 is because so far it has positive v, positive v, positive v, positive v. But v is getting lower as it's going up. The reason why v is getting lower as it's going up is because gravity is coming down. Once it hits the top, so let's say this is positive 10, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. It hits 0. Then it hits 0 here. It comes back down. It's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, right? Because it has negative acceleration. The reason why is because gravity is the negative 9.8 meters per second squared. That is what is causing it to go back down. Our kinematics equation can be written in terms of x or y, and when it's in vertical motion, like in our free fall, we write in terms of y. Here's the subscripts. Here in your formula sheet, you might see this as ay, but the acceleration in the y direction is always gravity, so you're always going to see this as gravity. Notice this behaves exactly the same way. Now, if you rewrite it in terms of displacement, which is delta y equals to y minus y naught, you're going to get these equation. Then lastly, if the object starts at rest, right, these value goes to 0, right, these values go to 0, and it simplifies into that. I want you to understand that the minus sign before acceleration reflects the direction, which is always downwards and negative. As a result, 9.8 or 10 meters per second squared are substituted as a positive value. Please understand that we use height, h, or the change in height, which is delta h, as the same as y and delta y. So you might see this sometimes as h is equal to negative 1/2 gt squared. Vice versa, you might see this as v equals to minus 2g delta h. Okay, please understand that these are the same. Okay, because we associate height as the vertical axis. Here are some variables, and to see what they mean, y naught and y are your initial, and y is your final. If it is positive, that means it is above the origin. If it's negative, it's below the origin. And if it hits 0, it's at the origin. Delta y stands for vertical displacement or your height. Delta h, which is your height. If the object ends, if it's positive, the object ends, motion is lower. If the object ends, motion is higher. And if the object returns to the initial height, it's still 0. You might see v naught y, which is your initial vertical velocity, as so on. If it's positive, it's going up. If it's negative, it's going down. And if it's 0, it's dropped from rest. V velocity in the y direction is your final velocity in the y direction. If it's positive, it goes up. Negative goes down. If it's 0, which is, you're never going to get that. G, which is the acceleration in the y direction. Please understand that. You're going to see that it's always 9.8, and you're going to substitute it in as positive 9.8, as the equation will always contain a minus sign already for you. You're never going to get a 0 gravity. When we solve the problem, it's the same way as what we did the kinematics. Step 1. Set up the picture. Here it says determine the object's maximum height that it reaches. So you can draw a person, right? I don't even need to draw the person sometimes. I can just draw the object, and we see that it goes thrown upwards with a velocity of 50 meters per second. And this is v naught. So that's your picture. Look for what you're looking for. It says determine the maximum height. So here they're looking for delta h, which is your maximum height. What variables do you have? Make sure you look for the hidden zeros and picture in the coordinate to assist in determining the correct values. So delta y, or h, is our question mark. V naught equals to 50 meters per second, which was given. V is equal to 0 because it is hidden in the word at max height. The object is at instantaneous rest. Remember, when it's at its peak maximum height, v equals to 0. We should see that in the picture from before. Then g is 10 meters per second squared. The hardest part about this is making sure you get all the variables together. Then now we are asked, what equation do we have that will give us our maximum height without a time component? And it's only this one. I'm going to now substitute in the values and solve for delta y. I saw that delta y becomes 125 meters. This is also referred as to your height. Okay, that is how much high it's going. But again, you should see it's the same steps as before. This is the only equation that has no time in it. Next, how long does it take to reach its maximum height? Well, we know we got the 125 meters from the equation from before, and now we can solve for time. You can either use this equation or you can use this equation. Either way, it works. This is easier to work with. Okay, this is given the fact that you know time and your initial velocity. So here you can plug it in. and you should get the same answer. You can use this one if you would like, but you're still going to get the same answer. So t, how I go from here to here is I just, again, v minus v naught minus gt. So subtract v naught, subtract v naught. V minus v naught equals to gt. Okay, then divide by g, divide by g. You get t equals to v naught divide by g. That's how they got this equation. Oops, I forgot the minus sign down here. Once they make the substitution in here, you get 5 seconds as time. So this is how much time it takes to reach its maximum height. So how long does it take to return to its starting point? Again, draw a picture. It's the same scenario. Now it hits here, then it comes straight down, and it returns to its starting point. This time we're looking for t because it says how long something's going to take. Okay, here are the variables again. We know that it's going to delta y equals to 0 here because our y was here and our y was here. Okay, delta y would be equal to 0 because there's no change. It returns to its starting location. We know its given velocity is 50 meters, our gravity is 10, and our time is unknown. We have to be able to solve for t. This is one equation that I can use to set it up. So I plug in 0 for delta y and so on. The reason why I could do this is because I'm now going to solve for the linear equation. So I first add 1/2 gt squared to both sides. In that process, it simplifies here. The reason why is because I'm trying to get one of the t's to cancel out. Now I multiply by 2g to both sides. There should be a 2g here. Oh, sorry. I multiply by 2 here. There should still be a g here. Yeah. Now I divide by the g. Once I divide by the g, I get t. In the end, you should get t is equal to 2v naught over g. Okay? The reason why the t squared and the t, if you have your delta y equals to 0, the t's will, each of the t's should cancel each other out. Once you plug it in, you get t equals to 10 seconds. Next, we add the time determinant from part C. And again, we are now going to ask for what is the final velocity. That's what the question mark is here. There's only one equation. Remember, once we solve for t, finding t is always crucial. If we ever get t, we can always get back to our simple equation of this one, that linear equation one. V equals to v naught minus gt. Don't use anything else complicating, okay? And use the simplest one, which is this one. Step 5, now you're going to solve and substitute. So plug it in, you get v equals to negative 50 meters per second. That negative just indicates its direction. So I can write it as v is equal to 50 meters downwards. Please understand, why is it negative v? The object was moving downwards as 10 meters, and down is negative on the coordinate grid. However, velocity is a vector, and magnitude of the vector are always positive. Therefore, we can write it like that. Okay. Part E. Oh, how does the time to the maximum height compare to the total flight time? We saw from part A that just going up is 5. Okay. That means at the same time coming down is also going to be 5. That's why the total flight time was 10 seconds. If an object returns to its starting height, then the time to this maximum height is half of the total flight, which makes sense because it behaves like a parabola. If it's going to take 5 seconds to go up, it's going to take 5 seconds to come down. So that's why they say here the If the object returns to its starting height, then the time to its maximum height is half of the total flight time. F, how does the time moving up compare to the time coming down? Well, we said that they were equal because the total should be just 2 times it. How does the launch velocity compare to the velocity when it returns to start? Well, at start, it went up at 50 meters per second. Coming down, it also returns at negative 50 meters per second. Remember, they have equal magnitude. They're just in opposite direction. Notice, these facts are only true if the object returns to its original height. If it lands lower or higher, then the initial and the final time speeds are not equal. The reason why is because these are very symmetrical. It's either it behaves like a parabola. Next, example 2. An object is thrown downwards at 50 meters per second from top of a 150 tall tower. Determine the object's height time. So you should draw a picture if you would like here, and it comes directly down. Okay, goes downwards at 50 meters per second squared, and I make this negative because we label downwards as negative. The acceleration is 10 meters per second, and we saw that the delta y is equal to negative 150 meters. The reason why I made this 100 and negative 50 meters is because I set this location here as y equals to 0. If I set this location equals to y to 0, everything below this is going to be negative. That is the reason why I essentially have a negative height per se. Okay? Because again, the object is below me. If I set up my equation, this is the equation that I'm going to use because I need time. Make the substitution in, then I'm going to rewrite it, and it's going to behave exactly like our quadratic equation here. So ax squared plus bx plus c. Okay, time always behaves like that, and then we can solve for it. We get t equals to 4.2, or you get t equals to negative 8.18. Let me show you this on the 15, and this is negative on the calculator. See, they calculated this, and here they got the answer, right? We can't really have negative time. That's why we take the positive value. Positive 4.17. Round it up to make 4.2. Okay? Because again, the negative time makes no sense. Remember, when we are trying to solve for time, and you end up using the t and the t squared, but in this case, the delta y wasn't equal to 0, so we can't rearrange it and cancel the t's. So we have to end up solving it using the quadratic equation. Now, there's actually an alternative method. You see how this had a quadratic equation? There's actually another way of doing it. What they did here is they actually solve for the delta v first. So they use this equation. So they use a first equation here to solve for v. Then they use the second equation here. Once they have v here, they plug in the v here, then they solve for the t. Okay, because notice that every single time we get stuck using the quadratic equation, there's always another method, and it's always using two of the other kinematics equations in conjunction with each other. Example 3. An object is dropped from rest from the top of a 4.5 meters tall building. So, and I want the object's time of flight. So t is still our question mark. A lot of these questions is going to ask you to solve for t. So the object dropped from rest, which is v naught equals to 0. The object moves downwards at 45 meters. So my delta y is equal to negative 45, because again, we set y equals to 0 here where the object falls. The acceleration is 10. Now you're going to need the equation. Again, we have to end up using this one. Okay. But normally requires a quadratic equation. However, the initial velocity is 0. So this bad boy goes to 0. So it simplifies. A lot of the times, if you have one of these, it makes your life so much easier. Okay. The other one was when delta y was equal to 0. That was when it came to the same point. But here, the delta, initial velocity was equal to 0. So that's what allowed us to do the cancellation. Okay. Solving for t, if you would like to see the algebra here, let me show you. Delta y is equal to negative 1/2 gt squared. So I'm going to multiply by negative 2g. So negative times, multiply by 2. So 2 delta y, then divide by g. Okay. That should get you your t squared. Then you square root it. Right? So either way, you're going to end up, you're still going to get the same answer of 3 meters per second. Okay. Now, it says determine the speed in which it hits the ground. That is your v here. But we know that our time was 3 seconds from the prior question. Using your simple equation. This equation, which is your linear equation, is always beautiful and easier, but please understand you will need time to do this one. But you know that v naught equals to 0 because it says it here, it drops from rest. That's why it simplifies into v equals to negative gt. Plug it in. The negative sign of velocity significates negative direction. The question asks for speed, which is the magnitude of velocity. So you can just write 30 meters per second. Or if you want to repeat it in velocity, you would say it had 30 meters per second downwards. Okay, that negative just means downwards. Just for you to get a little clarification. When an object is dropped from rest, the initial velocity is 0, which results in simplification of the displacement time equation. Dropping an object always moves downwards, resulting in a displacement that is always negative delta y. As a result, the equation would become negative delta y equals to negative 1/2 gt squared. Both of your minuses cancel out, so that's why you can just write delta y equals to 1/2 gt squared. Commonly, the minus signs are actually ignored for an object dropped from rest, and the equation is solved using all positive values. Please remember, this only works if the object is dropped from rest. One other note that I would like to mention is the way we're solving the equation. Notice that in a lot of the problems, we are asking to get time first. And when we need time, we end up using one of the t squared equations. Then we find velocity. That always works. That always happens. Every single time, it's always going to be solving t first, then getting the v somehow. Okay? In all of these problems, it behaves the same way. We always will have to find a way to solve for t first. Okay? So be very careful, but that's about it.